right, so quiz tomorrow on 4.6 and 4.7. So the first two questions say write the next three terms of the arithmetic sequence. So arithmetic sequence just means we add or subtract depending what the common difference is to get from one number to the next. So if my first term is 3, what would my second term be? 14, perfect, because we just add 11 to get to the next term. So 14, what would my next term be? 25, and then the fourth term? 36, perfect. I'm going to skip to number 3. So we have to find the common difference of the arithmetic sequence. So we have to find what number we're either adding or subtracting to get from one number to the next. What am I adding to get from 9 to 15? 6. What about 15 to 21?
6 again.
And 21 to 27?
6 again.
Awesome. So my common difference is 6. For 4, what am I adding or subtracting to get from one number to the next?
30.
Minus 30. Does that work for the next one?
Minus 30.
Yep. So what's my common difference?
Minus -30.
Negative 30. What about for 5?
5.
Plus 5. So what's my common difference?
That's a coincidence.
And then what about for 6? What am I adding? And does that work for the next one too? And the next one? Yep, so I'm adding 1/4. Perfect. So my common difference is 1/4. All right, for 7 and 8, we have to graph the arithmetic sequence. So it helps to know what our first, we have the terms, but we want to know what number of term it is. So what's our first term?
The first, 1.
Well, 3 would be our first term. 10 is the second term, 17, third, and 24 is the fourth. So we would graph these. The number of terms is our x value, and the actual term itself is the y. So I would go to the right 1 and up 3. This point would be 1, 3. The next point would be 2, 10. So I'd go to the right 2, up 10. Then I have 3, 17. So I'd go to the right 3 and up 17. So that would be off of our graph. And then what would my fourth point be? Perfect. 4, 24, which would be to the right 4 and up 24. So way, way, way off our graph. Up there. So when we graph any arithmetic sequence, we're adding the same number each time, so it'll always be in a straight line. All your points will end up falling in a straight line. You don't have to draw the line, just draw your points. Let's look at 8. So for 8, my first term would be -2. Second term is -6, third term is -10, and fourth term is -14. So here I would have 1, -2, 2, -6, 3, -10, and 4, -14 as my 4 points. So then we can go ahead and graph those. How would I graph 1, -2? So I go to the right 1 and then down 2. Perfect. For my second point, I would go to the right 2 and down 6. Third point, we go to the right 3 and down 10. The fourth point, we go to the right 4 and down 14. For 9 and 10, we have to determine if the sequence is arithmetic and find the common difference. So what am I adding to get from 12 to 17?
5.
What about 17 to 21?
4.
So would this be arithmetic?
No.
No, because there's no common difference. What about for 10? What am I adding or subtracting to get from 1? Plus 7. Does that work for -3 to 4?
Yes.
And 4 to 11?
Yes.
Yeah, so what's my common difference? 7. Awesome. For the next 4, it says write an equation for the nth term of the arithmetic sequence. We can skip those. That will not be on the quiz tomorrow or on the test. Let's look at 16. So the height in feet of the water in a tank each hour after opening it, drain, can be estimated by the sequence in the table. So we have the hours after opening the drain and the height in feet. You're not going to have to write an arithmetic sequence, so we can skip A. How do you think I could find the 7th term?
You keep subtracting 3 for 3 times.
Awesome. We got to know our common difference. So we subtract 3 each time. It gave us up to the 4th term, so I could find the 5th term, 6th term, and 7th term. What would my 5th term be? 6. What about my 6th term?
3.
And the 7th term? 0. So the 7th term would be 0. Because I just keep subtracting 3 each time. So for 1 through 6, we have to figure out which piece each x value belongs to and then just plug it in to evaluate. So which piece would I look at for f of -2? The first one, because -2 is less than 0. So I'm looking at the first piece here. So what do I plug it into? The x. So -2 times -2 plus 3. First, we have to do the multiplication. So 2 times -2 would be? And -4 plus 3? -1. Be careful with the signs. All right, let's jump down right below it to number 4. Which piece does f of 0 belong to?
The second one.
How do we know it's the second one? Because it has that equal to. So 0 would be equal to 0 here. So I would plug it into the x here. So I have 0 minus 5, which would be what? -5. So 7 is the same type of question. It just kind of puts it in words. So it says, on a trip, the total distance in miles you travel in x hours is represented by the piecewise function. How far did you travel in 1.5 hours? So 1.5 would belong to which piece? The second one. So how far did I travel in 1.5 hours? 82.5. Awesome. Because same reason we did for the last one, 1.5 is equal to that 1.5. So it belongs to the second. What about for 3 hours? Also the second one, because 3 is in between 1.5 and 4. So how far did I travel in 3 hours? 82.5. And then which piece would 4.5 hours belong to? The third one. So I would plug 4.5 into the x and solve. We can do it just for fun. So I have 82.5 plus 320 times 4.5 minus 4. What do I have to do first to evaluate?
If we do 4
I'm going to do the parentheses first. So remember PEMDAS. So I'm going to do the parentheses. So 82.5 plus 320. What's 4.5 minus 4? 0.5. Then I can multiply these two together. Does anybody know what 320 times 0.5 is?
160.
Awesome. When you multiply it by 0.5, it's like dividing by 2. So that'd be plus 160. And what is 82.5 plus 160?
242. Wait, no.
242.5? Perfect. So for 4.5 hours, it'd be 242.5. Don't worry about part B for that question. And then also for the next part, you do not have to describe the domain and range. We just have to graph the functions. So let's look at number 8. So when we graph piecewise functions, we do one at a time. So I have this negative x when x is less than 3. So we like to think about it in slope-intercept form. So y equals mx plus b. If I have negative x, what's my slope? Negative 1. And what's my y-intercept? 0. Perfect. So let's go to our graph. What would be the first point I need to plot on my graph? 0. Always graph the y-intercept first. How do I show the slope of negative 1?
Down 1 and to the left 1.
Down 1 to the right 1. So you always go to the right. If it's negative, you just go down to the right. If it's positive, you would go up and to the right. Always go to the right. So down 1 to the right 1, down 1 to the right 1. Just keep going. We want to make a full line at first, and then we're going to look at our restriction. X is less than 3. So I would put a wall at 3. Now I'm talking about x values that are less than 3. So which part would I keep?
The left side.
The left side, because the left side would be less. So I'm going to erase everything else to the right of 3. If it's just less than, do I have an open circle or closed circle? Open circle. If it's just less than or greater than, we put an open circle. If it's less than or equal to or greater than or equal to, that equal to means that we fill in the circle. So open circle, closed circle. So for the next one, I have x plus 4. What's my slope? 1. What's my y-intercept? 4. So what's going to be the first thing I put on my graph? 4. Always plot the y-intercept first. So I put a point at 4. How do I draw the slope of 1? Up 1, right 1, up 1, right 1. So I keep plotting points. I'm going to make a full line at first, and then I'll erase at the end. What does x have to be greater than? X is greater than or equal to 3. So I'm going to put a brick wall at 3. And which side would be greater, to the left or to the right? To the right. To the right is greater. So that means I erase everything that's less than, because I only care about the greater than part. So only keep the greater than 3. At this point, do I have an open circle or closed circle? Closed. Why? Because it's greater than or equal to. So that would be my graph. So looking at 11, for the first piece, what's my slope? Negative 1. What's my y-intercept? 2. What's the first thing I need to put on the graph? 2. So I'm going to put a point at 2 on the y-axis, because that's my y-intercept. How do I draw the slope of negative 1? Down 1 to the right 1, down 1 to the right 1. Remember, always go to the right. If it's negative, you just go down. So we connect our dots with a line. We make a full line at first, and then we got to look at our restriction. What's the restriction here? So x is less than 0, which means we just want to keep to the left of 0. So I'd put a line at where x is 0, and I only want to keep to the left of that. So I'm going to erase everything else to the right. Now here at 0, do I have an open circle or closed circle? Open. Because it's just a less than sign, so that means it's an open circle. Okay, let's do the second piece. For the second piece, what's my slope? 1. What's my b?
Negative 2.
-2. What would I put first on my graph? A point at -2. Always graph your y-intercept first. How do I draw the slope of 1?
Up one, right one.
Up 1, right 1, up 1, right 1. Then we connect our dots. Now it says x is greater than or equal to 0. So I'd put a wall at 0. Which side do we want to keep? Just keep the right side because the right would be greater than. Do I have an open or closed circle at 0?
Close.
Closed. This greater than or equal to means that it's a closed circle. So for the next two, we are writing a piecewise function for our graph. How many pieces are in number 12? 2. So I'm going to have y is equal to, and then that little squiggly, make room for 2 pieces. For the left side, so we always start from left to right. So start with the left. So for the left side, if I have y is equal to mx plus b, what is my slope?
-1.
Perfect. I go down 1 to the right 1. So my slope would be -1. What's my y-intercept? 3. I cross the y-axis at 3. So if I wrote this in an equation, it'd be y equals what?
-x plus
-x plus 3. Perfect. So my first piece would be -x plus 3. Now I need to see if this piece stops here. What x value does this piece stop at?
3.
3. So I would say x is what?
Less than or equal to 3.
Less than, we could say less than or equal to 3. Perfect. Because we're looking at the x values to decide where our graph stops. So it stops at 3. Let's look at the second one. So my second line, what's my slope? 1. I go up 1 to the right 1. So my slope would be 1. What's my y-intercept? Let's see, if I can't really see here, I can just extend the line. Just extend my graph here. So this would be -1, -2, -3, -4. So I would go to the left and down, to the left and down, to the left and down. So where do I cross? At -3. So B is -3. Yes.
Y equals x minus 3.
So y equals what, Dan?
X minus 3.
Awesome, x minus 3. So we're keeping the same form, y equals mx plus b, but our m is 1, and b is -3. So y equals x plus 3. X minus 3. X minus 3. Thank you. So that's a good question. I just kept the slope the same because instead of going up 1 to the right 1, I went to left and down to extend my line further. And I knew that if this line extended all the way straight, it would cross at -3. So that's how I got B as -3. Good question. All right, now my graph starts at what x value?
3.
It starts at 3. So I would say, is it talking about x values that are greater than 3 or less than 3? X is greater than 3. Typically, one of these would have an open circle and a closed circle, but since they overlap, one of them is going to get the less than or equal to, the other one gets the greater than. It doesn't matter which one's which. You could have put this as just less than, and this one's greater than or equal to. Just one has the equal to and one doesn't. All right, let's look at 13. So how many pieces do I have for 13? 2. So I'm going to have y equals my little bracket here, and I'm going to leave space for 2 equations. So I'm going to write them in the form as y equals mx plus b. For my first piece, which one do we want to start with, the left one or the right one? The left one. Always start with the left. Always go from left to right. So we're going to start with the left one. I need to figure out what my slope is and what my b is, my y-intercept. What's my slope here? 2. Just pick any 2 points on our graph. We go up 2 to the right 1. So this would be 2 over 1, which simplifies to 2. Perfect. What is my b? Where do I cross the y-axis?
-1.
Awesome, -1. So I have y equals what? Perfect. 2x minus 1. So y equals 2x minus 1. Now we need to write our restriction for the x value. Our graph stops here. So at what x value does our graph stop at? What's the x value that our graph stops at? 2. Our graph stops at 2. Are we talking about values that are less than 2?
Less than.
Yeah, less than 2. Awesome, less than or equal to, because it's a closed circle, so less than or equal to 2. All right, let's find the second piece. So for the second one, it's a flat line. So what did we say our flat line is going to be equal to? Y equals what?
0.
Y, no, well, our slope is 0, yes. But remember, when it's a straight line, it's y equals just a number. So what is our y?
4.
Perfect, so it's y equals 4. So when it is just a flat line, we have no slope, it's just going to be y is equal to a number. So it's whatever our y-intercept is, so it's wherever we cross the y-axis if we extend the line. 4 is our equation. And then we're talking about what x values here? We're talking about when x is greater than 2 or less than 2? Greater than, because it's to the right side of 2. So x is greater than 2. And it's an open circle, so that's why it gets the greater. So we're always, for our restriction part, we're looking at the x-axis. Where does our graph start or stop here? So our open circle here is at the x value 2. So these two restrictions always just talk about the x value. So we have to look at the x-axis for that number. I'm going to do number 10 also. I'm going to rewrite it so it's closer to the graph here. So if y equals x plus 6, x is less than -2, -2x if x is greater than or equal to -2. All right. So for our first piece, what's my slope?
1.
Slope is 1. I'm going to write it up here. So slope is 1. What's my y-intercept, my b? 6. So what's the first thing I need to put on the graph? 6. So put a point on the y-axis at 6. And then how would I show the slope of 1? Up 1 to the right one, up 1 to the right one. So we draw a full line first. Now my restriction is x is less than -2. So I'm going to put a wall at -2. Am I talking about the x values that are less than this or greater than this?
Less.
Less. So left or right? Left. Less than is to the left. So I erase everything to the right. Do I have an open circle or a closed circle here? An open circle because it's just less than. So I'd put an open circle at this point. Good with the first point? First line, first piece? All right, let's do the second one. So for our second piece here, what's my slope? Awesome, -2. What's my y-intercept? 0, perfect. Remember, this is in the form as y equals mx plus b. So whatever your number is that's being multiplied to x, that's your slope. And whatever is being added out here is your b. Nothing's being added, so my b would just be 0. what do I have to put first on my graph? A point at 0. Your B goes first. The y-intercept is what we graph first. How do I show the slope of negative 2?
Go down 2 to the right one.
Down 2 to the right one. Down 2 to the right one. Down 2 to the right one. I'm going to draw a full line first. Now it says x is greater than or equal to negative 2. So I'm going to put a wall at negative 2. X is greater than, so which side am I keeping? The right side of this wall or the left? The right side, so I erase everything to the left. Oops. Is this one an open circle or a closed circle? Closed circle. Because it was just, well, because it is greater than or equal to, so this means that it is a closed circle. If I were to continue this slope, so I think I just drew my line crooked here. Because if I were to continue the slope, I would go up 2 to the left 1, up 2 to the left 1. So it actually ends up being the same dot at negative 2. So it'd be a closed circle like that.